decide which model actually we have to choose. All right? Then I can go to my slides. Yeah. All right. So that was just a quick recap of some important points when it comes to assessing forecasting. All right. So I will, depending on how much time I have, but again, my idea is not really to go through my slides in detail. Whatever is helpful, and I hope we can have a good discussion here as well. So I talk about what consists of a quality of a forecast, what are the different dimensions that we have to think about when we want to assess the quality of the forecast. And then I talk about how we partition data, time series consolidation, and then discuss how we assess point accuracy and then distributions, which includes also prediction intervals and contacts. All right. So I think we discussed this briefly yesterday. Whenever you want to do something in forecasting, like you have a forecasting exercise or a task, the first question you have to ask yourself is, how forecastable this problem is before going into data analysis models and things like that. And so there are different dimensions to this, but maybe very briefly, can I ask, what do you think about this? What factors could affect the forecastability of a variable? Absolutely. So one important dimension is how much data we have. But also when it comes to data, there are, so you correctly mentioned, I usually say more history rather than like a lot of variables. So more history is better, probably helps me to build forecasting model. What else? Yeah, of course, yeah, the quality data also very relevant because you could have a lot of history, but different issues with there, so what then do you have to do? Yeah.
Sorry, I'll read you this. Just.
Okay, so the first thing I said is that quantity of data is more the time frame of data. So if we have only just data for 1 year, that's not forecast. But if we have data like 10 years, 5 years, that's more forecast.
Yeah.
And the second one is like more question to ask if I quite define outcome. That's hard to be set. It can't be like too diluted.
Yeah.
So for example, let's say you're trying to like make a composite index of a bunch of variables. I don't think that's forecast.
Yeah. I think that maybe when we go to, because one thing I will discuss later is the forecasting process. And actually the first part of any forecasting process must be about answering that question, which I call it, first you need to know why you do forecasting, so basically identify the decisions. And that should help you to determine the requirements of the forecast, which includes also what we said. So that should be important. Anything else that we can highlight here? So data is important, of course, is in quality.
I think the ratio between height and versus think we should.
Very good point. Absolutely, very good point. So sometimes you have phenomena where naturally you have a lot of randomness and noise. So if that is the case again, it's very unlikely that you can do something about it. Because remember, what is forecasting? Forecasting is about looking at the systematic information in the past, assuming future is similar to that, and we use that to project into the future. If we don't have much systematic and most of it is noise, it will be hard to go to. What else there?
Yeah, like this, yeah, it's too like short, yeah, it's already discussed. And too irregular. First is dengue is highly local. This is reported from particular district in some years, and there is no record at all in another year. So we have tested and found that this is also important issue, regularity. Because in fact, for 2022, large source was here, and after that, another district there is dengue. So we found irregularity. There is irregularity of the missing data and that.
Yeah. So again, going back maybe to quality and things. Yeah, so there are many, actually I have, so this is a link to a chapter of of our book. The text that I showed you the other day, and actually we discussed in detail what affects forecastability, but includes some of the important points you have that. Yeah, yes.
Just adding in like in this buying like time series, as Bauman said, it's more includes maybe that it's much more complex than the simple thing of like predicting some kind of like what we call classification, supervised learning, where you just want to say, based on some kind of data, give me a yes, no. So if you think of like, is a patient sick, right? And if you have some kind of information, blood sample, something like that, and you ask whether the patient is sick. Sometimes you might have 100,000 patients, which sounds like a lot, but only 5 patients were sick. Then it doesn't help with to have 99,995 that were healthy when you only have 5 that were sick. And it's a bit more complex to see it in the time series models, but I think it's a bit of the same thing that like, if you have kind of some kind of patterns you're interested in that are very, very seldom, then if you have a lot of data where there's almost no disease and very, very few outbreaks, that also makes it very hard. It's a bit more a gray zone, I would say.
Like imbalance.
Yes, like an imbalance, but it's in time series.
Yeah. So again, you can go to this link if you like. I mean, there are more elements there. So I just wanted to highlight that this must be the first thing that we look in. Is the thing actually is forecasting? If you don't have enough reason, well, don't go through all these transformers and deep learning. Maybe just do something simple that gives you some ideas, like a simple average or naive or seasonal naive, something like that. So you don't need really complicated ones. So I think with that, now we can start talking about, regardless of how you do it, you generated your future forecast, right? Now, how should I decide actually if this is good? What is a good forecast? So even before talking about that, I want to make it clear that when we talk about the good forecast, there are different aspects. One is the forecasting process. Because remember, forecasting is just not the modeling that you do with running the code and getting an output. There are a lot of things that are going on before and after it is. So we need to make sure you have a forecasting process in place. I talked about that a little bit more. But another aspect of good is the forecasting model, the model itself. So there are different aspects of the model that we need to understand to be able to judge if actually what we do is good or not. And then, of course, possibly the most important one that we care about is the forecast itself, the output of the model and the process. Right? So I'm going to discuss some aspects. I mean, sometimes it's hard to distinguish all of this because they're very interconnected with me, these different things. But you could think about these different things when it comes to what actually good looks like. Okay, maybe it's not very clear from thinking. So basically, in my opinion, and probably many more, and I think you maybe agree with me as well, having a good forecasting process in place is much more important than, if my forecast is accurate or is not accurate. Why? Because you may have a terrible process. You must be lucky that actually your forecast looks good. And then you say, but actually you don't have a process that is rigorous. So the first thing you need to invest on when it comes to doing forecasting is you need to make sure you have a forecasting process in place. And this forecasting process has at least 10 or more steps that we discussed this in our book. There are more details there as well. But two things that I want to highlight here is this. The process should always start by understanding the decisions that require forecast. All right? Now, could you give me some examples here of different decisions that you need to make? And for that, you need to actually forecast something. Sorry?
What else would hurt?
That's a very simplistic question. Let's go for something that is more real. That is real as well, but it's a bit in your context, like in the sort of work that you do. Yeah, can you give the example of decisions?
You have to make these problems people area getting it right. And probably observe that coinciding with the third trimester pregnancy for our
Very interesting. Do you think, is this a decision? No, it's not about forecastable, but is this a decision? Because you're telling me you want to get a probability. But actually the decision is the action that you take, is the choices that you make as a consequence of that. So what is the thing that you have to decide or choose, or options that you have, but you have to navigate between once you have that probability?
We have to decide which resources we are deploying to that particular facility. If the heat wave is, we get a probability of heat wave, and we identify there are ladies in the third trimester there, then we must deploy specialists, gynecologists, etc.
Perfect. So it's basically you have to make decisions about resource allocation, as you said, right? So, but that should help you to see, okay, so that's the first step. Identify decisions that require focus. Now, the next step in forecasting is I have to determine my requirements. Okay, so what could be the requirements here? The first thing is I have to decide what is the variable that I need to forecast. Is it the number of cases? Is it the number of deaths? So what is that exact value? That's the first thing you have to determine. The second thing you have to determine is the horizon. Is it, you have to just do it for next day, 2 days ahead, 7 days ahead, maybe 2 months or so. So that's the second thing. The third thing is about the granularity of it. Do you need it daily or every week or every month? But remember, this is sometimes very confusing because I have worked with people that tell me I need the model to forecast 3 months, but actually they mean 90 days, right? So this is why it's actually common that people, this is how they communicate. So they say 3 months and you do a 3 months model and it goes perfect. Oh yeah, but I actually meant days, not in 3 months. So that's the other thing. But another important aspect that you have to determine here is also how you want to assess your forecast, right? For example, if you tell me that you care more because you want to you don't want to take much risks, and you want to go for a quantile of 95%, right? So that's what you care about. When you generate the distribution, here, you go for this right tail and you take the 95%, and that will be the number that you take and you action on it. Now, do you think I can evaluate that number with mean square error or with mean absolute error? If you do, it's wrong. Because the way you have to assess that is different from the way you have to assess this point in the middle. This requires a quantile score. This requires root mean square error or mean square. So it is very important that the decisions dictates basically what you need to forecast. And actually, yeah, so now I remember if these were questions now. So going back to how many horizons do I do 3 months or 6 months? That should be dictated first by the decision. Let's say if I do forecasting for logistics and supply chain, I have to order, and the lead time for my products is 6 months, right? So I order now, I receive it 6 months later. I have to, in my calculation, make the estimation for demand over the next 6 months, right? I don't do 12 months because that's not very helpful for the decision I want to make because my lead time is 6 months in this case. So in this case, I have to go for the 6 months. But also the forecast horizon is dictated by other things, like the length of data. So imagine you have the data for, let's say, 120 days, and you want to forecast for 365 days. This is not possible. So again, that limits also your choices, like what should be the realistic forecast horizon. So at least these two things are crossed my mind now that you have to consider when it comes to horizon. So the horizon should be dictated by the decision, or it should support the decision. So you shouldn't do something that is not really helpful for the decision, and then also consider the density of the decision.
My question may be like, I think that important the dictation should be based on accuracy. So we may say then, for example, if the horizon is 12 weeks or 12 months, so the minimum accuracy we may need might be like 80%. So I think that that's important. So when we speak for the listeners, we can say that okay, the model accuracy is a minimum of 80.
So can I?
The larger the horizon might be probably the lower the accuracy. So I think
Yeah, but so I agree with you, the larger horizon, but again, I'm not here to write papers. We are here to make decisions. Okay, that's the first thing. So I have to do things that support my decision. Otherwise, why I do what I shouldn't be doing? Leave those decision maker people making their decision. Because once I met a decision maker in NHS, so he told me, look, I make decisions with or without forecast. I have to make decisions. But of course, I like if it is informed by the sort of modeling that, but I have to make them with or without. And that's all. What I'm saying is you have to do things that actually align with it. Another thing about what you said, in my opinion, you cannot measure things based on how much accuracy you can get. I have it in my latest slides. We have to understand there is a limit to improve forecast accuracy. We shouldn't chase forecast accuracy by improving 1%, 0.5%, and whatever. And that goes back to my first point as well. We need to understand, is this thing forecasted? So there is a limit that we can do that. So if there are companies coming to you and say, I have a magic solution, I can improve your accuracy by 80%, they're lying to you. As simple as that. Or they want to make money, of course. They want to get a good contract and their bank later. The topic many times, but yeah, I have seen this sort of thing. For example, I don't name the country, but I have visited countries in Africa, for example, where they get bonuses based on how much improvement they make in mean absolute percentage error. All right? So the performance is evaluated by them. This is so wrong. But then, yeah, of course, you can tell those people this is because that's how you do it. But also, yeah, this is quite common actually. People, they say, my minimum accuracy should be 80%. But this is not the right approach to forecasting. To just set things and which is what it means, like 80% accuracy. If my time series is not even forecastable, how should I achieve it? So yeah, we should avoid that sort of discussion.
Yeah. Just to add a bit on that, because I think it can be part of an iterative discussion, and you also discussed the feasibility, right, Simon? So one thing that you could also say is that maybe the malaria program will say that, well, we want to plan next year's allocation, so we want to do prediction 12 months ahead for malaria. And then you could say that, no, sorry, that is unpredictable, right? We will not be able to do that. But we could do 2 months. And then you can say, are there some decisions that you could do in the malaria program that could be done in 2 months? Because if so, we could work together. If you see what I mean. So it could be part of this initial feasibility.
Yeah, no, but the thing is, I mean, we are not making one decision in organization, we are making hundreds of different decisions. And again, my understanding is each decision, wherever you have a decision, you need a forecast, whatever you call it. You may not call it a forecast, you may in your head make some calculation of how these things may change in the future, it is summer, it is winter, this is how we check. You may do that sort of thing even in your head, not Excel, not paper, nothing. But still, you make some estimation. So, and in organizations, you make hundreds of decisions. And some of them, at least, should be based on rigorous assessment of forecasting. So, yeah, I think the point I want to make is you shouldn't go into the analysis of modeling before knowing those things, like what are the decisions I want to make, and how the forecast is informing them, and then how the decisions that I want to make determines the forecast. Basically, I want to do.
Yeah, we have a couple of questions and comments. I'll just take a round if it's okay, Ramon.
Thank you very much. So my question goes back to the idea of replacing data. In order maybe to replace the network address. My question is replacing data based on the covariance or the volume of data? Volume can mean number of rows. So, now, if it's increasing the number of covariance, what are the possibilities? Like when I did the data evaluation, I found that most of the covariance have a very weak correlation. So, what's your advice on when are we which covariance are we going to take in relation to the
Yeah, well, I mean, first of all, the question about the length of history or samples or number of, actually, I have done a really nice simulation, but I cannot show it here. But you could do a simulation that shows once you have, let's say, thousands of columns or variables, and I generated them randomly, I found so many correlations between randomly generated columns that are related to my outcome, just by chance, because I generated them randomly. So one danger is this: once you have many, let's say, columns, one danger is, sometimes things could be, or there is a confounder or something between them, or somehow related, but then you're not helpful really later, and then it becomes worse. So my always recommendation is to have more history if it's available, rather than having more variable. So one way would be, in my view, to do a domain knowledge. That would be my starting point. Use the domain knowledge, understand a handful number of predictors that impact, right? So that would be my first thing. So go identify. I mean, if you have the domain knowledge, great. If not, talk to people with domain knowledge and see what are the things that affect them. Of course, next thing would be whether data is available for those variables or not available. And as you say, I have done this myself. People tell me this correlates with that. I look at the data, there is no correlation. So, and that goes back to, maybe there are issues with the data then. Maybe that it doesn't capture really what it should and so on. So there are other ways then. I'm sure you're familiar with methods like lasso, for example. So that you have many variables and then gives penalty to certain, and then it helps to also do that. But I think in reality, in many cases, if you have a good number of predictors that are related to your outcome, that will do the job.
And just to add on that, I think like sometimes it's some covariance of variables that's very easy to add. Like if you have a climate data, right? Anything in here of like humidity, rain, max temperature, average temperature, you can easily throw them in. But something like malaria intervention data might be very costly. You might need to digitize a lot of archives. But maybe based on domain knowledge, as you say, malaria interventions is probably much more valuable than adding like some so it's a balance of, I think if you have to think about the cost and then think in the domain knowledge, is it worth kind of digitizing and
Yeah, so the cost is a really important point, because sometimes we also forget about that. And I talk about the data leakage later as well in forecasting. But one thing that we forget about, so you tell me, sorry, just let me finish this. So basically we say we have three variables. What I want to say. Let's say we have three variables, and you tell me, look, I look at the data, these three variables are very related to my outcome. But the reality is we forget. Something is changing in the approach this. So the reality is you forget that you may need to also forget those variables. You see what I mean? This is something we call it ex-ante and ex-post. So let's say if you say, oh, temperature is perfectly correlated to the cases, right? At the same time. But again, I think this is something we have discussed before, no? So we have three different types of things. We have covariates, which means we are looking at the same period relationship. We have lead variables, or we have lag. So lag is easy, as I think we discussed. Temperature in the past with affected cases, but sometimes we may have lead as well. Things that happen in the future may affect the past. For example, imagine if there is a new regulation like what's happening non-stop in the US, there is a new regulation, you cannot do something. But that regulation will be in place in a month's time. But that you know that that happens in the future, but it will maybe have an effect now. But so lag, lead, covariate happening at the same time. But if you have covariates, and now you look at the data, it looks good actually. They are quite moving at the same time, but you forget that I don't know the temperature in the future. I have to forecast it, and that brings a difficulty to the forecast. Right?
Get on some short questions.
Yeah.
I think.
Question.
Okay.
All right.
There was also a question. Yeah.
Issue. One has to do a forecast for 3 months and after we subside to different things levels. Now it's in the forecast wrong failed. The later have a wrong classification of this.
I didn't get the question. Sorry. Yeah, I think if the end result is like these three risk levels. Yeah, green, yellow, red.
Yes.
So, I mean, again, this is something I think we briefly discussed with here. So let's say this is a distribution you get, right? So for every distribution you get, you can get this is the PDF. You can get the CDF of it, cumulative density function.
And the PDF is not the
The file type, the probability density function. So basically, so imagine this is if my next period is here, let's say. So this will be the probability of my next period. Different possible outcomes, different likelihood. I could have the equivalent of this, which is my CDF. All right. Again, remember here you have different outcomes. And actually what you said, this is what I recommend, because for me, the classification things, and again, this goes back to the, what was the name, exceeding threshold?
yeah.
That goes back to that discussion as well. So that is for me is a decision-making problem. Actually, how you decide which threshold, in my opinion, it depends on circumstances. It depends on the constraints that you're facing. And this would maybe change over time as well. So I shouldn't stick to one threshold and say this threshold tells me if, let's say, the probability is between 0 and 10, then I do this or classify this from that. But anyway, if you have the probability distribution of the forecast, you can get a CDF, and actually you can use this to classify things. So this would be one class between this probability and this probability, another class, and then the rest of it would be this class as well. But as I say, this may change over time. You may say now I decide 10% to be the lowest, but maybe next month if you do this, things change, constraints, logistics, and the domain, your domain knowledge, basically, whatever you observe, you can change this. So, but the approach that you're, I think, suggesting is more like a classification thing, that in advance I label things as classes and I forecast. I think my approach wouldn't be probably that. My approach would be to get first this, and then get the CDF, and then play with the threshold based on the reality or the things that you see in the future.
So I think one advice I would give there is to say, like, if the ministry says, like, tell me is it green, yellow, red in the way, then since as Bauman says, our numbers of cases is uncertain. Meaning that if we want to say it's green, yellow, red, that needs to be uncertain. So you have to say that you cannot expect me to say for sure this will be yellow or red. But I can tell you that I think it's a 10% chance for the red area and 40% chance for the yellow and 50 for the green. And I think like you have to insist on that uncertainty also when you do the classification.
All right. So, well, it seems like you are very interested in forecast evaluation, but so I have many more interesting things to talk about. So let me ask you another question. So now imagine that you produce your forecast. Whether you are interested in the point forecast, in prediction interval, or in the full distribution, doesn't matter. What can you consider as a good forecast or a good forecasting model? What are the criteria that you have in mind to assess if this is good or not good.
Yeah, I said, I think it depends a bit on what kind of decision are you thinking. Is it like a cost-effective decision, or is it like very expensive? So yeah, so
Cost effective, again, I suppose, could be different things, right?
or costly or cheap. Yeah, yeah, maybe more precisely say is a costly decision or a cheaper decision. We say it's like how many resources does it take that decision or cost.
So, yeah, I mean, you mentioned resources because I have exactly the same word in my slides that you see, but that resources for me could be different things because I need resources to make focus. I need human resources, I need data, I need software, I need electricity, all of this. So that's one thing. But I think another thing that you may be talking about is more like the decision value or decision impact of the focus, right? It could be again cost, but it could be the service level, how many people benefit from actually my forecast. If I forecast correctly, I wouldn't have maybe much stock outs and actually service level will be better and so on. But so, okay, one, let's say, is that resource. Another one, what else? Sorry? Ease of use. Yeah, very good, very good. Yeah, it goes, but that feature or quality goes back to the model, I would say. Is the model easy to use? Another term that I would use for that, actually, there are two things that will touch on that. One for me is explainability. Can I explain it? Another approach for me is about, I call it either updatability. Is it even a word? Updatability or debuggability, right? Maintainability, right? Can I debug it easily? If something happened that I know is wrong, can I go and change something that actually helps me to make better progress? Yeah. So very good point. Ease of use. I have 2 points already.
I guess, you judge, you assess whether your forecast is weak or not, depending on where you stand. For the ones making a decision to forecast something that's close to reality.
All right. So basically here you're referring to the forecast accuracy. How accurate that forecast is. If let's say reality is 300, a good forecast is if I get 290, 305. All right. So that's something you refer to as forecast accuracy. So a good forecast is a forecast that is accurate. Very good. Yeah, what else?
Linked to his answer. So does it help us make a decision? Is it reusable or is it too niche?
Very
And
good.
by asking if this model is reusable, I also want to kind of reduce my technical debt. So
Very good.
you're going to have transitions in your program, and when you hand over this model to the next person, do you have so much technical debt that they cannot work with your model because it only lives in your brain? And
Very
not
good,
theirs?
yeah. That's brilliant, yeah. So there are a couple of terminologies related to this, at least in academia we use them. One of them is reproducibility. So basically reproducibility means you generate the exact thing with the exact code, right? You give me your code, I run it, I get exactly the same thing. Because if it's not reproducible, what you did, then it means I can't do much with it, maybe. It's not science. But then, as you said, after that, maybe my first step would be to reproduce. Once it's actually exactly like the code I gave you, Harsha gave you, or the code I also provided. My first approach would be, you reproduce exactly what I cut. What would be the next step? Replicability, reuse, generalize, this things. But the first step is reproduce. And then the following things, reusability, generalizability, conceptuality.
Yeah, I think that the lead time of forecast is the important component because the intended goal of forecasting is to do some intervention at this time. So is the lead time enough for preparation and for?
Yeah, very good. Actually, I call this, I don't know whether, let me see if you are talking about this. I call this timeliness. Because as you say, you may do a lot of forecasting, but is it actually arriving on time for me to use it to make decisions? So if it is not helpful, again, why you do all of this really? Because you're not writing papers. And it's okay with me because I write papers, I don't mind. I just do things and run and write papers. And no one cares, okay? Between us. But then you have to make decisions. So in organizations, someone should ask that question. If actually all of this you do is not timely for me to inform a decision, why should I be doing this? So very, very good point, thank you. So yeah, thank you so much. These are really very important points. So I put some of them here, but it will be more than this as well. So the first thing that most people look at, as the point you mentioned, is about accuracy. How close the forecast is to reality. And actually, this is what I'm going to also talk about for the rest of the sessions. And then, following accuracy, again, I think some of you mentioned about the utility of this. So what is the business impact of this? What is the business value of the forecast that I generate? Because remember, whatever decision you make, it has multiple inputs. One of them is focus. I think you mentioned very correctly that whenever you make decisions, there are many constraints, logistical things. And actually, I gave an example. I don't know. So I gave an example of imagine this situation. You are doing forecasting for pharmaceutical supply chain. And then you are battling between a forecast of 25 number of products or 70 number of products. Which one is better? But actually, that product comes in a box of 100. So actually, you're doing the wrong thing because you missed the business side of it, right? Actually, this happens a lot in forecasting. We are trying to improve 25 to 70, decide which one is better, but that doesn't matter at all because this quantity is 100, the minimum is 100, right? So that's where business becomes very important. So another thing is about resources. The first thing you need to think about is the data, okay? So now maybe you build a model, you generate a model, and then you produce the forecast. How easy it is for you to do this every time, right? What if you use the data from Met Office and they stop actually sharing that data, right? What would happen to your model? The model would be useless in that case. So the data, the quality of it, the storage that you need for that, but also the quantity sometimes. You need to think about that aspect as well. Expertise. You can understand the regression model, maybe exponential smoothing, that is seasonal. So, and then I think most of you can easily manage that. How you can manage transformers and foundational time series models. Okay. So again, if you think about you are building models, you need to think about, do you have expertise actually to continue doing this? Do you really understand what is going on? Another thing is about the process time. Imagine if you have to run a model that takes 24 hours. And if you have to do this every day, it just doesn't work. Right? So you need to think about that sort of thing. Which is also related to another aspect that is, I call it running time. Effectiveness, but also energy consumption. Especially now with AI models and foundation time series models becomes important. As we spend a lot of tokens on that, and then does it really worth it? I'm not sure. I don't think so. So that's another thing. So again, for some reason I made a mistake here. I put two: understandability and explainability. But explainability is also, I think, important because, honestly speaking, if I'm a decision maker, I am more happier with a forecast that ends, right? Rather than something that I have no clue. But again, that also links to maintainability and debuggability. So you see when it comes to how good the forecasting model or forecast is, this is just probably not one thing that they need to look at. So it's a trade-off really. It's a trade-off between different things. For example, if you go from model A to model B, and this improves 5% forecast accuracy, but the running time increases by 300%, are you happy with that? So it's a trade-off. So but when it comes to trade-off, you need to basically think about this different aspect of how much time do I have? I just lost 20 minutes.
Yeah, we take a break.
Okay, just now. Okay. All right. So this is one thing that
it's just.
All right. So I think talk about this. I think one thing that maybe I reiterated, everybody really needs to think about this carefully, is there is a limit to improve forecast accuracy. We need to understand that. So having like error metric in organization and saying we need to improve this by 90% is, to me, is just nonsense, right? So this is something we need to have in mind. Yeah, another important thing is about decision making and whether actually the forecast we generate creates the decision or not. So how can we do that? Very briefly, there are two approaches you can do it. So one approach would be, as you do forecasting, so you generate a forecast, and then you can calculate the errors and so on, but you could also measure the decision. I mean, for example, one thing could be stockouts, okay, because you make a decision about replenishment and ordering, so and then you measure stockouts in each month. And then now you can actually build models that helps you to say, is there a relationship between forecasting and forecast accuracy and business value? Can, by knowing the forecast accuracy improvement, get an idea of how much I improve? So that's one way. I put it here. But the second one that is actually the more closer reality is you have to build simulation models. So for me, this is a bit maybe touching on something that people also call it digital twin. So when you have one version of, so you have the reality and you have a visual version of the reality, right? But anyway, this could be simpler than that for one single decision. So you could build simulations and you have inputs to that simulation and you have your other inputs as well, because forecast is just one input. And then you can see how actually forecast translates to the solution. So this would be the second way and better way, if you like, if you want to know how forecast accuracy translates to business impact. I think I talked about this. So I talked about understandability, explainability as well. Yeah, debuggability. All right, so just now before going into a bit technical side of how we actually assess metrics and so on, and this is something I think Knut will do tomorrow. Do you show that tomorrow? How we assess forecast accuracy with the point estimation and or someone else? Yeah. But anyway, someone in the team is showing you this, but I also have R codes that you can look at later as well. So before going there, I just wanted to maybe discuss, okay, there are different dimensions to what actually a good forecasting model or a good forecast is. And you need to think about different things, not just the forecast accuracy. But unfortunately, the reality is in many cases, we come down to forecast accuracy. And that's why I'm planning to discuss as well, that hopefully we can move on in the future to talk about other actually aspects of this a bit more detail and better and actually doing it as well. Okay, so now let's discuss one more thing. It is here. Yeah, so maybe I want you to imagine when it comes to the taxes forecasting, if you were doing it for real future, how would you assess this forecast? Because we first need to understand how we do it in real life, and then come and try to mimic the real life situation when we do that. So that would be the idea. So if I am here and I have to forecast for the future, how would you assess that in real life? So if I'm here, I have to forecast for 3 next months. Well, the only way for me to know how good my forecast is actually to wait 3 months, get the actual 3 values, compare it with forecast, and then now I have an idea how close my forecasts are to reality, right? And I could keep doing this. Next month, let's say, if this is the end of February, this is the end of March. So by the end of March, I have my actuals. Now I can actually add this to my previous observations. Again, do that for the next 3 months. And then now I can also observe how, well, if I do that, then maybe I include, because I reviewed the 3, I include the 3 actually now. And then I forecast for the next 3 months. So do you see what, this is what we do in real life. So there are a couple of things that I am actually explaining as I do this. So one of them is, when I use my train data and predict for the future, so my estimation is only based on the data here. I didn't use anything from here in the past. That's why I call this a forecast error. This is why I call it residual. So I calculate my errors based on the forecast errors, based on the new data. And then each time I produce a forecast, 3 steps, review them, include them in my past forecast for the next 3 months and so on. But do you think there is an issue with this? There might be an issue because I have to make a decision. I have to provide the forecast to my boss now. So I have to decide actually which model is the best now, not in a year's time or 3 months' time or 4 months' time. All right? So I cannot probably wait 1 year to know everything, how my model performed in a year. By the way, I recommend you to do it. I recommend you to always monitor your forecast and see how well or bad you're doing, and also identify reasons behind it. But here we are trying to actually do different things. So by doing this, I want to tell you, we try to mimic the real life situation. What is happening here? And that is the idea behind time series consolidation that I will introduce now. Before actually getting to time series consolidation, I want to also highlight some pitfalls that normally we deal with in forecasting evaluation. So the first one is the data leakage. Anyone? I think this is not too difficult to understand. Just anyone wants to explain what is data leakage?
I think maybe just an example is that if you are using the things that the AI is producing to train the AI, then it ends up in this loop and it goes kind of insane. Yeah.
Actually, yeah, this is a good example. I don't know if at the beginning you have used ChatGPT or Anthropic and so on. Basically, of course, Anthropic and ChatGPT, they have no clue what is time series models or forecasts. They just go and say, oh yeah, there is a time, there's this numbers there, and then it seems like this is similar to that, they copy those numbers. Now actually things are slightly better, but still with those generic things, they don't work. So that is one example of that. But very common in forecasting is, let me give you an example of weather forecast. Because typically we have weather, the actual daily temperature of weather, and we use it in a covariate to forecast the cases, for example. But sometimes, hopefully, in most cases unintentional, but we don't. So let's say in my data, I split my data into train and test, and then I use the actual values of the weather in the future rather than the forecast. Because I have the past value, I split it into train and test, and I use the actual in my model. But in reality, I would never be able to actually get those actions. And if I do that, I may say, oh yeah, the actually weather forecast was brilliant because it helps me really. But then we forget that actually I use the actual values of the weather in my model rather than their estimated value. So basically, the idea of data leakage is I'm using unintentionally some values from the future in my model, either training or even model evaluation sometimes. So we need to maybe avoid that. Another thing that I want to mention is about inappropriate benchmarks. Remember, in any forecasting, you need to always have benchmarks. Benchmarks are typically simple or something that you currently do. If you have a transformer in your model and you benchmark it again, another transformer, maybe not a good idea.
Could I also throw in one more example of data leakage that we have seen in several public papers in the field? So it's a bit good to be aware about. And so if you remember this autoregressive model that we had yesterday, right? And we talked about what you do is that you predict one step ahead and you want to predict 3 months. So what you're going to do now in March, in February, is to predict for March. And then we kind of, as Baumann says, we kind of put that value predicted for March. We use that to predict April. Now we put in the one we have for April predicted, and we are going to use that for May, right? So we will kind of build on predicted values when we go ahead. But when you do the assessment, what many people do actually is to say, well, we go back in time, right, and pretend to be there. And then we predict for March. And then we see how wrong we are. And then we use the real values for March to predict for April. And then we use the real values for April to predict for May, one step ahead, right? And it's like this subtle little thing. I think it's unintentional for sure. But of course, it means that you have predicted 3 months ahead, but in reality, only 1, because you always cheated by putting in the value 2 months ahead, which you could not do in a real situation. So be aware of all these it's very dangerous to go back in time and do this evaluation.
Can I just ask, because I think that's also what we have to see in some application, that it's very hard to say wherever the people that have made the model have actually tuned it based on how the forecast was, the assessment part of the data set. So I could actually trust predictions when we don't know whether they have kind of cheated. Or when your model is not good enough, it's very tempting to just adjust some parts and then you have a good model.
Yeah.
And nobody can say whether that's valid.
Yeah. Well, the thing is, again, we hope that people they have good intentions. Otherwise, yeah, I mean, sometimes it's possible actually to do things that make things closer to that by cheating things. But again, I think here the idea would be we want to inform real decisions, and if you do that, then of course you will see the consequences because you have to inform decisions. So, yeah, there was one thing I just forgot I wanted to mention. Sorry. Yeah, anyway. So another thing that maybe we have to go at 3 o'clock.
Right.
Yeah.
Well, yeah.
So another thing that you actually sometimes we miss is selecting evaluation metrics that do not align with business goals. Think about again the quantile that I mentioned. So what you care about is a quantile when you assess your models based on between squared. This is a misalignment. Or sometimes you may use mean absolute error, and then knowing that there are a lot of issues with mean absolute error, including very low values and zero values that make it even not actually usable for us. So you need also to think about that. And again, that goes back to the first step in the forecasting process. Identify decisions, and then for each decision, identify forecast requirements, including how I should assess my forecast. Sometimes having a small data set also would be difficult. And this is where we should look for other alternatives, like using information criteria, for example. Another thing that I wanted to mention is over-reliance on plots. Because, one problem with if we just rely on plots, visualizing forecasts against actual is we actually look at how horizontally, because that's how our eyes perceive it, how horizontally these 2 lines are close to each other and we think, oh, this is great. But actually, our errors are calculated vertically, and our eyes would miss them. So errors are calculated vertically, but these lines are sometimes close horizontally, and we say, oh, this is good, but actually it's missing a lot of things. One example of this is the naive approach. If you train it, you will see horizontally they are very close, but vertically they could be actually very different. So again, you need to be careful with that. All right, so now maybe I can have an introduction to this, and then we can have a break. So again, so far we're just discussing some really general points that you need to have in mind when you want to assess the quality of your forecast. Now, as I said, my idea from now on would be I'm actually using just the forecast accuracy and trying to show now what is the best way to assess the quality of the forecast using forecast accuracy based on the error metrics, using the point forecast, prediction interval and quantiles, and a full distribution. All right, so remember we said when it comes to assessing, we want to mimic the real life situation. All right, that's the first principle. Now I have the time series. I have the time series from here to here. And assuming again this is like now and this is the future. So we said we cannot just forecast and wait for 1 year in the future to assess actually what happens. So we need to look for alternatives. So what is alternative? I use the whole data I have, right? And I try to see how I can mimic the real life situation. So that's where data partitioning comes. Basically, I take my whole history, I divide it into 2 parts, different names, train and test, or in sample, or out of sample. And then I forget this. I pretend this is my future. All right, so this part that so basically I split my historical times into train and test. And then I forget about the train and pretend this is my future. I don't use it in my fitting and training. All right, and then what happens then? This will be my first time series. And then once I have this, if my forecast horizon is 3 months, then I forecast for 1, 2, 1, 2, 3. The next, I have to decide how many of this I will add to the previous one. And this is something later you see in the code I show you. We call this a step. A step is equal 1, it means to add 1. So I'm referring to the R code. So I just add 1 month to this. If its step is 3, I add 3 months to the previous one. And actually, this refers to something in reality, which I call the forecast frequency. How often do you generate your forecast? Let's say by the end of February, I generate the forecast for the next 3 months. When you regenerate the forecast? Is it end of March? Or is it what will be the 3 months from February? March, April, May? Or it will be the end of May. If it is every month, then your step would be 1. But if it's 3, it means you are here, generate a forecast for 3, and after 3 months, you add this to the previous one, and now you generate for 3 months, and then after that, again, after 3 months, you generate. Do you see the difference? So we call it the forecast frequency. Let me tell you about the daily forecast. Which day is today? Wednesday. So if by the end of Wednesday, I have to forecast for next 7 days, right? That's I generated now. Now, the next time that I want to generate a forecast, if it is tomorrow evening, my step is 1. Because every day I generate a forecast. But if the next time that I generate a forecast is 7 days later, my step is 7. So every 7 days I generate a forecast for any horizon. That's why we call it forecast frequency or step efficiency.
My question is, so the process that you just described now, what is the difference between that and data leakage?
So here, as I said, I forget about it. I pretend doesn't exist. So where is the data leakage? I'm not using anything from here to train my models. So I just believe I have only this data. All right. So I don't use anything from here.
You're using what you generate.
Exactly. Yeah.
And you're using that to that.
Yeah. It is like this. So first, this I don't know anything from here. I just take this, generate the forecast for 3 months. And after this, I could review this data, like in reality, basically. After 3 months, I can review reality. And then I add them to the previous month. Right? So that will be my next thing. And then now I have to forecast for again next 3 months. The next time, this will be my train data. Then I forecast. So each time, when I review, I add it to the previous one. So there isn't going to be any duplication. So basically now, each time I have the forecast, and then I have the actual corresponding to them. All right? And I keep actually doing it until I have only 3 observations left, and I cannot do more because I'm gone. So it's the end of my time series. So this process that we do, we call it time series cross-validation. So now I have errors. So for each, actually we call this ID, you may see it later, or we call this also origin. Forecasting with rolling origin is another way for another name for this. We call this ID. If you later see it in your R code, we have IDs. So this is one ID, ID1, ID2, ID3. And then how many you include each time, we call it that step. So this could be any number, 1, 2, 3. So in this case, I just gave you an example of 3. And then now this is how we calculate errors, basically. And this example is for the point forecast, but we could do the same thing for prediction interval, quantile, and for distribution. So I calculate the difference between each two. This will give me errors for each period. And then later, I calculate a summary of these errors. We call them scores. Again, I calculate the average of these errors, and I'll show you later how we do it.
I can just throw it very quickly also that like it's very important that one does this time series cross-validation. Because what also we have seen been done quite a bit in the field is that they say, we want to predict, let's say, we pretend to be in 1st of October. So we remove October, November, December for last year and try to pre-close. But we keep the data for this January and this February, right? And that is like, and then of course you can see that there was quite little malaria maybe in September, but it was like huge in January. And then the model can see that, oh, it should start to increase, right? But that is not at all realistic, because nobody would say, let's now try to make the forecast in March, April, May, and we already know what happens in June and July. That's a special kind of time machine.
Yeah, so basically another thing that related to the point Gail made is, one reason we do this, because as I said, if we rely on just 1 3 step ahead, it's easily too risky to say a model is doing a good job or not. Because as Gail said, maybe something happened during that period and your model is not actually doing that, but maybe it is doing well later. So it is important to assess the model over many steps. And this brings the question of, okay, when I partition my data into train and test, how many I put in my test, how many I put in my train? There is no exact rules. Again, it depends on how much data you have, the granularity of it and so on. But as a rule of thumb, let's say 20-30% always can go to test, 70-80% go to the train. But let's say if I have daily data, and I have 10 years of daily data, and I want to produce a forecast for every 24 days, for example, actually I always use 1 year of data as test, because I want to see how my model performs across all days of the year. So that's another example. So I don't follow the rule of 70-20. Instead, I always go for one full year and test my model across all of this. I'm saying, is there anything else that I want to I had here before, yeah, just sorry, one, yeah, so that's fine.
And how should we take into account if our data is kind of demand, how do we think that out of this that
So again, my understanding is when we do partition here, we are talking about the time series. So I need to keep the order of my data. So whether seasonality happens here or there, it doesn't affect my seasonality. Maybe if you do the machine learning, that would be a different approach, I would say, to the time series. But in time series, what we do, we always go to the last observation, and then we leave out whatever number of observation we want to be the test set, and then the rest of it would be the training from the old to the new. So we preserve that basically order when we do the time series classification. That's
But also to add to that, I think I see where the question is coming from also is that if you have like malaria and it has a strong seasonality, it's important when you do these origins or the IDs that I think I would advise try to have 12 of these or to cover a whole year, because if you only put like 3 origins and all of them are like without of malaria season, you can be very good in your predictions and ways and your forecasts, but you haven't tried them out in the part of the year when there's big.
yeah. So yeah, again, maybe I see what you mean. But for me, again, that goes back to the number of observations you have in historical data. Let's say if you have 15 years of monthly data, so we could actually use easily 4 or 5 people data on the test. But I don't know what is the typical horizon you do in malaria. Is it 6 months, 4 months?
Typically 3 months,
3 months.
10 years.
Yeah. So basically, if I do that, then I have 48 observations, 4 years in my test set, and that covers a lot of seasonality and everything. And then, so every time, if I have 48 minus, so how many samples? I call them samples. This sort of thing. How many of these 3 steps ahead you get, right? I think in that case it would be 48 minus 3 plus 1. That would be how much? Would be 46. So basically you test your model and 46 different 3 steps. And if it doing well there, you could do it, but also you could look at the errors. That goes back to the question of error analysis. I could look at the errors across each step or across all the origins that I'm making. And I show you how to do it in the ARPA, the distribution of the errors. But yeah, I think, so one thing that I notice sometimes talking to people in machine learning is about the confusion between time series, cross-validation, and cross-validation. So in what differs this is, in time series cross-validation, we have to preserve the order of the time series. But in machine learning, you don't need to do it. There are actually some cases of machine learning you could use with time series data. You have a block, let's say, of 12, 3 months or whatever, and that block preserve that, but that actually works with a certain number of machine learning. So I think that's the idea behind what we're planning to do. So we want to apply time series classification. And basically, this is the most robust way to assess the forecast accuracy of your model. So if you want to be sure, you have to do that. But then there are a lot of nuances around this. Again, if you don't have much history, let's say if you have only 24 months of data, and you have to forecast for 12 months again, it's very difficult to do it. So you have to think about other things. But if you have enough data, enough history to split into train and test, without losing much to actually train your model learning from your data, then this is the most robust way to assess the quality of your model. So if you do this and you tell your manager, this model is actually the one I want to use because I have rigorously assessed that, you should have been following this information. And this actually is what we need to do. And then I think after the break, considering what we have discussed so far, we just go and talk about, okay, if I'm just interested in the quick estimation, how I should do it, and then later talk about the distribution. So I think I should be able to do this in half an hour. And then we could have 1 hour where you go through the R code, because we can also run and see how we calculate this. Right?
Yes.
So that was right now, yeah?
Yeah, and perfect timing for a break. We take a break until 3:30, so that's 18 minutes. I'll start chasing it in 16 minutes.
Yeah.